Okay, chemistry students, now we're going to talk about writing chemical equations. So when you write chemical equations, you need to remember that the reactants are written on the left side of a chemical equation. Products are written on the right side. An arrow pointing to the right means yield. First step, you write the correct formulas for each of the reactants. You put a plus sign between the reactants to separate them. In a word problem, a plus sign will mean added to or reacts with. So an example would be hydrochloric acid reacts with silver. So you would have hydrochloric acid plus reacts with silver, and you would put Ag. Second step is you draw a yield arrow. That is just an arrow pointing to the right. Third step is you write the correct formulas for each of the products. And remember, you put a plus sign between the products to separate them. Step 4, you need to balance the equation. Example, let's look at our reactants. It says a solid piece of zinc reacts with hydrochloric acid. So we have zinc, reacts with means plus, and then hydrochloric acid. To produce, so that means that we have an arrow to produce a solution of zinc chloride and hydrogen gas as the products. So the first thing we need to do, a solid piece of zinc. Well, we know that zinc, or you should know that zinc is Zn, and I'm going to put an S behind it to indicate that it is a solid piece. Reacts with, so now I'm going to put a plus sign. Hydrochloric acid. Now we're going to have to remember our acid naming rules. Hydro and ic and acid. All right, acid means that it begins with an H plus. Hydro and ic. I ate something icky, ate an ick, it ends in ick, but it also begins with hydro, so that's not going to work. All night I was nauseous, it ends in ick, not ite, so that doesn't work. When I took a ride on a hydraulic plane, hydro-ic, all right, that works. A ride on a hydraulic plane. So on that, we take off the hydro, we change our ic to ide, and we have chloride. So chloride is right here, chlorine. We change our IDE to INE. Chlorine is Cl. It's in group 17, which means it has 7 valence shell electrons. So its oxidation number is a -1 because it is easier to gain 1 electron than lose 7. You gain 1, that's your oxidation number. So I'm going to put this over here. You have your H plus and your Cl minus. This 1 goes down by the H to make an H, and this 1 goes down by the Cl to make a Cl. We never write our 1s. So that is our formula for hydrochloric acid. Now it says to produce a solution. So I know I have to put my yields arrow because it says produce. A solution of zinc chloride. So once again, we need to find out what zinc chloride looks like. We know that zinc is a Zn. And zinc is located right here on the periodic table. It is one of the transition metals that does not change its oxidation number, and it has an oxidation number of 2. We will look at that right up there. So zinc has a +2. We already know chloride has a -1 charge. So I'm going to put Cl -1. That 1 goes down by the Zn, and we never put 1s. This 2 goes down by the Cl. So the formula for zinc chloride is ZnCl2. It says it is a solution. That means that it is aqueous. It is dissolved in water. So I'm going to put the AQ behind there. Here it says and hydrogen gas. So I'm going to put a plus because there's an and. Hydrogen gas. This is when you need to remember the last video, our diatomics. Hydrogen is a diatomic, which means it exists as 2, H2. It is a gas, so I'm going to put under here a subscript of G that says gas. Now we have just done all of our 3 steps. We need to balance. So let's balance. Remember, we do our metals first. Zinc right here is a metal, so I'm going to put it down here. Next step is polyatomics. We have no polyatomics here, so I'm going to go to the next one, which are nonmetals. Our next nonmetal is Cl, so I'm going to put Cl, and then we do hydrogens and oxygens last. There's a hydrogen here. All right, let's balance our metals first. Over here we have 1 zinc, and on the product side we have 1 zinc. So our zincs are already balanced. Now let's do our Cls. On the reactant side, we have 1 Cl, and on our product side, we have 2 Cls right here, Cl2. So we have 2. We need to balance them. We need to have 2 on the reactant side. So this is the only place, HCl, hydrochloric acid, is the only place that we can add another chlorine. Remember, we have to add to the beginning or the front. We now have 2 Cls. Now let's balance our hydrogens. Over here, we have 2 hydrogens on the reactant side with our 2 HCl, and over here on the product side, we have 2 hydrogens with our gas. We are now balanced. This is a balanced equation. Guys, if you cannot write these formulas correctly, then you will not be able to balance these correctly. It's very important that you know how to convert a word into a chemical formula, a word formula into a chemical formula. It's very, very important that you know how to do this. Okay, let's go on to the next example. All right, we have sulfuric acid is reacted with a solution of sodium hydroxide to produce a solution of sodium sulfate and water as the only products. So the first thing we do is write the formulas for our reactants. What we have is reacted with, so sulfuric acid has to be one of our reactants, is reacted with, so this is a plus sign. This is where we're going to put a plus sign. A solution of sodium hydroxide. Then it says to produce, so this produce, to produce, we will have an arrow there. A solution of sodium sulfate, so this has to be one of our products, and this and tells us that it is a plus sign, and water as the only products. So we have sulfuric acid, sodium hydroxide as our reactants, sodium sulfate, and water as our products. So let's do our acid first. Sulfuric acid, all acids start with an H plus. Sulfuric, I ate something icky. Well, this ends in ick, so that means I'm going to change the ending to ate. In sulfur and phosphorus, we always take off the UR. So this is sulfate. If we look on our polyatomic ions under sulfate, which is right here, it is SO4 with a -2 charge. So up here, SO4 with a -2 charge. That 2 goes down by our H, which makes it H2. This 1 goes down by the SO4, and since there's only 1, we don't need to put it, and we don't need to put the parentheses. So the formula for sulfuric acid is H2SO4. So I'm going to write that down here, H2SO4. And then it's reacted with, so I'm going to put a plus. Sodium is right here. It is in group 1, and it has 1 valence shell electron, which means it is easier to lose 1 than gain 6. So we're going to have Na plus 1. And hydroxide. Hydroxide is found on your polyatomics and is located right here. And it has an OH minus. So I'm going to put a parentheses and an OH minus. This is a parentheses. The 1 by the OH minus goes down by the sodium, and we never put 1s. And this 1 down by the hydroxide goes down, by the sodium, goes down by the hydroxide, and since there's only 1, we do not need to put parentheses. So the formula for sodium hydroxide is NaOH. So I'm right here. Now it says to produce, so I'm going to draw my yields arrow. A solution of sodium sulfate. We already know that sodium looks like Na. And sulfate, we already know, is SO4 with a -2 charge. This 2 goes down by the sodium. This 1 goes down by the sulfate, and since it's 1, we don't need to put parentheses. So the formula for sodium sulfate is Na2SO4. And, so I'm going to put a plus sign, and water. You should know that the chemical formula for water is H2O. Now it says here a solution, so I'm going to put aqueous for a solution. Now let's balance. First thing we do is balance our metals. The only metal we have here is sodium. The next thing we do is balance our polyatomics if they do not separate and change. So here our polyatomic is SO4, and on the product side it stays as an SO4, so I'm going to keep it as an SO4 down here. The next one we have is an OH. If it stays as an OH, this polyatomic stays as an OH on the product, then we can keep it as an OH. But it does not, so we need to separate them into its hydrogens and oxygens. So we always do oxygen first, so I'm going to put oxygen here and then hydrogen. We've accounted for all of our elements, now we need to balance. We're going to balance our metals first. Over here on the reactant side, we have 1 sodium, and on our product side, we have 2. So we need to make sure that we have 2 sodiums on our reactant side. The only way we can do that is put the coefficient in front. We now have 2 NAs. Now let's do our sulfates. So we have 1 sulfate over here on the reactant side, and we have 1 sulfate over here on the product side. Now let's do our oxygens. We do not count this oxygen in our oxygens down here because we've already taken care of our sulfates. Okay, so we do not count this oxygen here. Now we do have 2 oxygens right here. 2 times this subscript of 1 is 2. So we have 2 oxygens on the reactant side. And now let's see how many oxygens we have over here. We do not count this because we've already accounted for this oxygen and the sulfate, so we are not going to count it again. We're only going to count this oxygen right here, and there is 1. We need to put another oxygen on the product side. So we need 2, and the only way we can do that is put a 2 in front. Okay, we now have 2 oxygens. So now we need to do the hydrogen. We need to account for this hydrogen because we have not done that, and we also need to account for this hydrogen. So we have 2 hydrogens here, and we have 2 hydrogens here. 2 times 1 is 2. So we have a total of 4 hydrogens on the reactant side. Now on the product side, we have 2 H2Os, and each H2O has 2 hydrogens. So 2 times 2 is 4. We have 4 hydrogens on each side, so we are balanced. Now what I would like for you to do is practice this problem on your own and the next one, and then come back and check your answers. Okay, go ahead and check your answers. Practice this problem and then come back and check. Okay, check your answers. What I want you to remember is that silver has an oxidation number of +1. You guys are done.